Non, je peux dire. OK. Il est supposé recevoir le report sur ma tablette, mais je ne sais pas si ça va aller ou pas. C'est ça. Ça dépend. So I think we're good from our side. So I think we can start.
Awesome. Sounds good. So I saw that you started recording. That's great. I'll have you keep recording, and then when the meeting is done, you will just send that to Ezra. There is a link to instructions in the first email I sent you regarding scheduling video review. But to start off with, I figured that we'd just go and give quick introductions for the people that are in your room and on the Zoom, just so I know who I'm talking to. So if you guys want to go ahead and start with that.
Okay, we can start. So working on the rockets now, we're in the meeting. We're currently two. So there is me. I'm the lead for the aerostructure department on this rocket. On this rocket, we have two rockets this year. So I'm on this rocket particularly, and we have our avionics also.
Hi, so I'm Nathan Armisha. I'm working on the avionics for the Spaceport rocket. Yep, that's pretty much it.
So I guess we'll introduce ourselves as well. So my name is Olivier. I'm Université Laval's mentor. Just a little bit of a background. I helped, kind of restart the rocket team about 10 years ago. Was aerostructure lead for a few years, and then remained as a technical advisor throughout my graduate studies. So I've been following them for a while, and I'm still their mentor now.
I'm André Chaquette. I'm the how you call it? The how you call it, Justin? My role.
Flyer of record, yes.
Yes, the flyer of record. I'm a level 3 for Tripoli. I'm a prefect of the prefecture 51 in Canada, and I was a flyer of record. I start in Utah, in the old when there was a 15 team total, I think at that time. So a few years ago, yeah.
Awesome. Well, it is great to meet you all. I'll give a quick introduction for myself as well. My name is Erica Bovey. I've been the person who's been emailing you all year regarding feedback on your progress reports. So this is my first year volunteering with Ezra. I am a safety reviewer, and then at the competition, I'll be doing more safety reviews and also being one of the solids pad managers. Before Ezra, I was a student. I went to the University of Minnesota. I was part of the rocket team there, so I competed in a Spaceport America Cup for a number of years as a student, but now that I've graduated, moved off into industry, I am simply returning to come back and volunteer some more.
Good.
All right, so to get started, I want to preface this meeting with the same thing that I had said in the email to you all, and that is that this meeting is purely for safety review. You are not judged on this, so you do not gain or lose any points. We are here with the goal to uncover any potential safety issues, reasons that you might not pass the safety reviews, reason that you would definitely not pass the safety reviews, anything along those lines, just to help prevent uncovering issues at the competition that are not feasible to fix in a hotel room. So that's our main goal here is to make your experience at the competition a little bit smoother, to try and catch issues earlier on. And so we'll do kind of an overview of the rocket. I kind of want to see everything that you've built so far. I'll have a list of questions already, and anybody else can jump in, add questions or comments. And then at the end, we will go ahead and turn it over to you guys to answer, or to ask rather, any questions that you have at this time regarding the competition. Because from my understanding, it's the first time your team has competed in Spaceport in a while. Is that correct? Or are you a returning competitor?
2019, yeah, and we haven't been there since the pandemic. So, yeah.
Cool. Well, it's very exciting that you are able to return. So I'm going to turn it over to you guys. What I'd like is just some sort of a general overview of the rocket. So if you have a camera and you can show me what it looks like, or I know some teams prefer to have like a presentation. So if you've prepared that, we can go over that. If you haven't, that's totally okay. And we can just kind of do a quick step through of your rocket, and then we'll go into more detail on all the components.
Okay. All right. So I can.
We don't need to show the old avionics.
Yeah, we can. So we have our rocket right in front of us right now. The paint job is not made yet, so it's kind of looks a little rough, but it's here. Just gonna focus on there. So the rocket itself is right here. Okay. So yeah, this is what the exterior it looks so far. So I don't know if they're part of it. Yeah.
I was just gonna say, if you want to kind of walk through like what's in the nose cone and maybe start top to bottom and just kind of point out where all your components are and maybe like what they're
Okay.
made of, just like general basic info about them.
Okay, so general. So the nose cone is a 4-1. It's a von Karman form. So currently we don't have the nose tip. It's still machining right now. We have the section where how it will be fitted into the nose cone. So we just need to pop this out when the machining will be done. Then we have our sure pins also installed. We have 3 sure pins. They are 440 sure pins. We have our main parachute right here. I think you can kind of see it there through the fuselage. It's a 120-inch parachute. It's rad, so it was homemade a few years ago. We used it at last year competition in Launch Canada, and we recovered it without any damage. So we're using it again this year. Right in the middle there, our avionics bill will be installed. We currently, I think I sent you our email, but we have our bulkheads are made, but they currently are not. They don't perfectly fit in the rocket. We have to put them on. We have to shave a little bit of them. So currently the avionics bay is not in the rocket, but we have it right there, so we can make a little. How can I say it? We can see it later. So. And right down there, we have our drogue chute. Drogue chute is a 24-inch. We also have 3 sure pins, as usual. We also have Nomex sheet to protect our parachute since we are using a black powder. So it's yeah. So, and right here we have the booster section. So we are missing the truss plate. So there is the 2 parts that are left to be machined is the truss plate and the tip, so it's kind of on both end side of the rocket. For the fins, they are a carbon fiber center, so we have a core carbon fiber, and then we have 4 layers of fiberglass tip to tip. And yeah, for centering wing, they are made from they are 3D printed from resin. We have tested the temperature to make sure that the motor would not melt them, so we can kind of see them right there, of the rocket. And yeah, we have also a motor too. So we are using a 98mm motor for this year that is already at the competition. So yeah, basically, and yeah, it's a 4-fin model. So yeah.
What's the rocket's diameter? Maybe just to put things into perspective.
It's 5.6 inch. It's perfect for a CubeSat format payload.
And how long is your rocket overall? Or how tall?
It's 2 meter 88 centimeter. I don't can make the conversion in inch. I don't know it exactly. 88 inch.
Okay, sounds good. All right, so I have a kind of a list of questions and a number of things that kind of popped up just from your brief overview. So we can start, maybe we'll go back to the top and we'll dive in starting at the nose cone.
Okay.
So the first thing I saw was right on the inside of the tip there, you had what looked like some way that you're going to be attaching your nose cone tip. And that looks like that's 3D printed. Is that correct?
It's Onyx 3D printed.
And what material is that made out of?
The 3D printed material. It's called Onyx. It's from a company.
Oh.
Yeah.
Got it. Sounds good. Just wanted to make sure that that was not PLA and that would hold the temperatures well in the desert, but it sounds like it will. And then what is your nose cone tip going to be made out of?
It's aluminum. So it kind of has a bolt in it. So we bolt it on the inside, and we usually seal it in resin just to make sure we don't need to open it later again. So usually it's completely sealed.
Okay. And then in your nose cone, is there anything in there, or is that kind of where the parachute sits?
It's where the parachute sits. We're gonna have a bulkhead right there, which is we need to fit it again. It's made, but again, the fitting will be made tomorrow. And we are planning to put a little I think Nathan can not the GPS, but we have something in Newscom now.
No,
Gyroscope?
that was
Okay.
that was kind of a long time ago.
Okay.
We talked about an extra gyroscope in the nose scope, but
Yeah. So yeah, basically we have the parachute's gonna fit on those. Nothing there.
Okay, and you said that you've flown your main parachute before, is that correct?
Yep.
Okay, can you confirm that it's in good condition so that there aren't any burn marks on it or tears or holes or anything like that in it?
Yeah, we confirmed it. We opened it a couple of times since the competition last year, and there seems to be absolutely no damage on it. So yeah, can
Sounds
confirm.
good. Great, yeah, that will likely be checked in person at your safety review, so just want to make sure that you're aware of that.
Okay.
And also similarly for your shot cord for your main parachute, how long of shot cord are you using and what size and material?
It's made from Kevlar. It's around. I think this one's a little bit longer. It's around three times the length of the rocket, or 2.5. It's around there. I don't know the exact, but it's between 2.5 and 3 length of the rocket. So.
Okay,
And
yeah.
From Kevlar, 1.5 inch on it.
Got it, yeah. And so similarly for the Kevlar, just make sure that there's no burn marks, that it's not slightly torn anywhere or getting worn out. If it's new, I'm sure you probably don't have that problem, but if it's stuff that you've used before, just make sure you give that a thorough inspection to make sure that there's no damage to that.
Okay.
And then also you said that your shot cord length was around 2.5 to 3 times the length of your rocket?
Yeah, around that.
Okay. I'm not saying that that can't work. It can definitely work. However, personally myself, and I know a lot of other safety reviewers, we like to see it just a little bit longer, definitely more in that 3 to 5 times the length of the rocket. Some people lean more towards 4 to 5 times the length.
Okay.
And there's a few reasons for that, particularly at Spaceport. One of them is just having to do with your launch angle. As I'm sure you've probably seen in the rules, you launch at a bit of a higher angle, usually around 4 to 6 degrees.
Yep.
And often what teams see as a result is at your deployment, particularly for your drogue, but it's not necessarily irrelevant for the main as well. But particularly for the drogue, you'll have a lot higher horizontal velocity when you're deploying.
Okay.
That
Yes.
sometimes, yeah, it can sometimes leads to higher shock force or just more yanking around on there. And so it can be seen that having a little bit extra shock cord to help dissipate that load
Okay.
is beneficial as well. So even if you're not putting it in, I definitely make sure that you're bringing some extra with you to Spaceport. So when you're getting that final inspection, if they're like, we'd really like to see some more, I can't guarantee that I'm going to be the person doing your inspection. It could be any one of our safety reviewers. So I just want to make sure that you're aware that that may likely be something that comes up, and it'd be really good to have some extra on hand, so you don't need to scramble at the last moment to try and get some.
Okay. Yeah, I'll keep that in mind. Just it's impossible. Merci. Yeah, we can go to it after, but the cord from our drogue is made from a nylon instead. So maybe I don't know if there are any concern about this, because I know people usually like to have Kevlar, but
Yeah, for nylon, I would be more concerned if it's something that's been used maybe even more, especially just, are you guys using CO2 for deployment or black powder or?
it's a black powder deployment. So
Yeah, kind of, especially if you're using a lot of black powder, because then you can kind of see it start to maybe melt away a little bit easier and more often. So definitely make sure that you have shock cord that isn't damaged for down there. Similar thing with the length, make sure you have at least 3, preferably like 4 times the length of your rocket in shock cord. And so for your black powder charges, have you been able to do ejection charge testing with those already?
we're waiting for the bulkhead to be fitted, but we already have our power deck chargers right there. So we have 2 right there. So they will be fitted tomorrow, so they will be done very quickly. So, and our compartment are kind of very similar to our last year's rocket, so we kind of already have a guess at what black powder will be needed for ejection. So.
Sounds good. Yeah, that's good to hear. And you're using a primary and then a backup ejection charge for both your drogue and your main, is that correct?
Yeah, exactly.
Okay. And then for going back to your shot cord quickly, how is that attached to your rocket? Are you using like U-bolts, I-bolts, and where is that attached?
We are using I-bolts, so they are. I have to check. I think they are 1/4, but I will confirm. 3/8. Yeah, 3/8 I-bolt. They are fitted onto our bulkhead, so we have a bulkhead right there, and so there will be I-bolt, and we have another bulkhead, so there will be another 3/8 I-bolt pointing down. So, and it's the same thing right there, and our bulkheads are fitted with M5 screws directly from the exterior of the rocket. So this is how the force is dissipated into it. So.
Sounds good. And just a couple reminders for those I-bolts. Make sure that you're using a nice big washer on the backside of it just to help distribute that force over a larger area. And then I'm also wondering, do you have any methods in place to prevent that I-bolt from potentially spinning and coming loose during flight?
We have a swivel link on our parachute cord, so we have we have one on each parachute. So this is the main thing, and we usually put Loctite in it just to be sure, just to make just to be even more sure that they don't spin around. So
yeah, definitely like to hear the swivel. I know it's not really a common failure to see those come undone, but it has definitely happened before. So just make sure, yeah, like you mentioned, that maybe even in addition to the swivel, consider what else can you do to make sure that there's no way that I-bolt spins. I've seen teams use things like cotter pins before and castle nuts. Otherwise, just simply having some way that physically stops that I-bolt from being able to rotate. Some people will tie it off with Kevlar on the bulkhead or use some sort of a pin or a rod to make sure it doesn't rotate. So I want you to consider that closely, make sure that there's no possible way whatsoever that could possibly come undone.
Okay, so they use so they have lock screws basically, like on those, because we have those. They are lock washers. I'm sorry. I know I've seen some people use them, so I don't know if I've seen if they could be useful in that case. But yeah, we'll think about it. So
yeah, I've definitely seen people use lock washers before. I don't think they're quite as foolproof as having something that mechanically stops the I-bolt from moving. But I'm not going to say that like that's a reason to fail a safety review, but I just want to make sure that you are considering that during your assembly to completely eliminate that possibility of failure.
Okay. Perfect. Sounds good.
All right. And then another thing that I've seen a number of teams happen actually just this year is during some of their testings, when their drogue parachute deploys, their main parachute and those shear pins might end up shearing as well. So I just want you to consider, you don't necessarily have done this now or give me numbers right now, but what are you doing to make sure that when your charges eject for your drogue parachute, you're probably going to see some forces on your rocket and things are going to get yanked around. What are you doing to make sure that that main parachute isn't going to shear through those shear pins as well, even if the charges haven't gone off?
Yeah, I see. This is this has to do with the wind, I guess, at Spaceport and the angle of. Okay. So our shear pins are three. We have three 440. So I don't know what the other teams add for shear pins. It's not a problem for us to add more in case something like this can happen. But usually, yeah, they break at 140 Newton of shear stress. So yeah, we probably can make some calculation with that and anticipate any problem with it. Yeah.
Yeah, I don't see any inherent concerns with using 3 of the 440 shear pins, but it also a lot of times comes down to your weight and how much weight you have in the nose cone. Also. So if you're a very top heavy rocket, that could be more of a concern. So I'd encourage you to just do even some back of the napkin math just to make sure that the forces that your rocket's seeing isn't also enough to shear those shear pins.
Okay.
All right. I think we can kind of move past the main parachute area, and then my understanding is below the main parachute, you have your avionics unit, is that correct?
Yeah, it will fit right there. Yeah, all the avionics and the payload will fit right there.
Okay, and did you say that you have that outside of your rocket currently, or is it inside?
Currently, it's outside of the rockets.
Okay, can we take a look at that?
Yeah. Currently, it's a 3D printed. It's a 1.5 view right now that we are the format. So yeah.
Does this also function as your payload?
No, the payload will fit on under or on top. We're still there. We're
Okay.
still the payload is way it weighs more, so we are currently still. It might be on top because will be more stable. It might be under, so we're still discussing it.
Okay, sounds good. And could you tell me a little bit about what flight computers you're using to deploy your parachutes?
Don't mind that.
Well, these are the COTS flight computers. So the Stratologger and the Easy Mini. They were both tested at Launch Canada last year. And this is the SRAD one that we've been developing. It's almost 100% functional, I'd say. We still have a few bugs to iron out, and but the main features are there, and we have to test it more deeply. But yeah.
Okay, and will that SRAD avionics port also be hooked up to your black powder charges, or will that just be for data collection?
That'll be the main flight computer, so it will ignite charges unless something goes horribly wrong, and then we'll have two backups. But we should normally only need one COTS and our SRAD board.
Yeah, we still have a slot for it in case, but yeah, the main goal is to use the main one. So.
Okay, and have you flight tested the SRAD board before?
Nope.
Okay, I will note that it is a requirement that if you're using an SRAD board for your controlling your black powder charges, you will need to have that flight tested before the competition. Okay. I'll tell you a bit about a very common failure that is seen at Spaceport America Cup, and it's with SRAD flight computers deploying charges on the pad, meaning they turn on their flight computer, they haven't tested it thoroughly enough, and they fire the charges. And then a very common failure, in addition to that with SRAD boards, is they just don't fire the charges at all when they're supposed to. And so because of how often you've seen that, I mean, last year, I think it happened 3 or 4 or more times. It's definitely a high point of concern and critique for these custom avionics that are controlling them. So having a successful flight test is very important to using that at the competition, just to avoid any potential injury or failure to deploy or any of those other issues. Those are kind of some of the worst case scenario failures that we would see. So are you currently planning on flight testing the board?
Well, by flight testing, can like a partial test, like multiple partial tests be good enough, or it has to be a full flight test?
What do you mean by a partial test? Could you explain more what you had in mind?
Well, I mean, testing stuff like not flying it in a rocket, in a smaller rocket, like doing drop tests, vacuum tests, igniter tests and stuff like that, testing everything separately, and maybe, yeah, that's pretty much what I had in mind.
Yeah, and those are all really good tests to do and things that I would recommend doing before you do an actual flight test. But in the design test evaluation guide, the rules and requirements for Ezra, it is listed that it is a requirement that it must be flight tested before it flies. That being said, I think that if you don't have enough time to flight test it, it's still worth having on board on your rocket, but just not having it connected to any black powder charges. Because I can see you already have 2 COTS flight computers, which if you have both of those connected to your charges, that's great. Those are known, reliable boards to be working with. But then you can kind of have the Spaceport America Cup be your flight tests of sorts. Again, specifically not having it connected to your black powder charges, but being able to collect data, analyze that data, use it as a GPS receiver, assuming you've done all the necessary GPS testings in the rules, but that is an option if you're unable to flight test it before the competition.
Okay.
And you can do a flight test on a subscale rocket. It doesn't have to be on your competition rocket, but it should still cover a similar enough flight profile. For example, if your rocket's going above Mach 1, your flight test should probably go above Mach 1. If it has high acceleration, your flight test should have high acceleration as well, just so you know that it'll be accurate for your flight conditions that you'll be experiencing at Spaceport.
Okay.
And then on your SR flight computer, is that also where your GPS tracker is?
We have a GPS tracker on it, yes, and this is its antenna right here.
Okay.
And we can't get any signal in the basement here, but we get a quick signal outside. We haven't done extensive tests yet, but that was planned.
Yeah. Is that your only GPS then, just the SRIDE one?
We have a cut further right and backup also. So
Oh, okay, that's good to hear. Yeah, I would still recommend thoroughly testing your SRIDE GPS on the ground. When you are at the competition, you must be able to confirm that you have active telemetry before they will press the launch button at the pad. So you want to make sure you have something that's good and reliable. And that's why I love having two, is just in case one of them isn't working and it's acting up on the day of, you'll have that backup option.
okay,
Good.
And what frequency does your SRAD flight computer operate on?
What you mean, the processor, or like the?
Oh, the telemetry, like, is it the 915 megahertz? Is it 434, something else?
It's a 900 megahertz, I think, in the 900 megahertz band.
Okay, sounds good. Yeah, I just wanted to make sure that you would have any necessary licensing for radios.
the
Yeah,
license
yeah, no.
otherwise.
900, then you're okay.
Yes.
One other question then on your avionics bay is, how are you going to be securing your batteries to your structure?
So that's going to be a separate module. In here, it will have basically compartments for each battery and to slide them out.
Okay, sounds good. Yeah, what I'm mainly looking for is just to make sure that there's no possible way for them to come loose. So if it's feeling a little flimsy on the ground, it's too flimsy to fly. A single zip tie is not enough necessarily to hold them in place. So something that will not only withstand the heat, but also just be able to withstand all the acceleration you'll be seeing. And then that also goes for the connectors you're using. I can see you're using an XT60. I like those. I think that they hold together great, but just make sure that you're considering how that acceleration will affect your battery connection so that they don't move around and cause damage and that they don't become disconnected.
Okay.
Okay.
I think that's all the questions I have for now on the avionics bay. Do you have your payload as well on hand?
We don't have it right now. So, but the format is exactly the same as our avionics bay. We just need to there's some machining to do on it. So yeah, we don't have it currently right now, but it should be it will be basically the same in terms of look. So.
Okay.
Camera modules though, it's as they count as payload, I think, but they own the camera modules.
Yes.
You have the first.
And remind me again, what is your payload? Is it a functional payload, or are you using a boilerplate mass?
I think Nathan can answer better on this, but we have inside of our payload we have another concept for a SRAD computer on it. That's completely different from this one. We're kind of using two concept, and we also have a data. How can I say this? A data gatherer, I guess.
Yeah, the payload just has its memory secured basically in the more structurally sound payload bay.
Yeah.
That'll be, what was the payload?
It will. It's one. It's in order to get to 8.8
Pounds?
pounds. It's kind of it's made from steel basically, so it's kind of a steel structure with memory stored on it in case something goes bad.
Show the cameras. So this is the kind of design we had last year. These are camera modules, and we decided to integrate the batteries directly inside the module for simplicity and because the cables broke off at the last competition, so we didn't want to repeat at that. So we've made them bigger. This is just a prototype though, it's not final. But the battery fits in here and powers the cameras for the flight. We don't have a remote activation, so I think we calculated yesterday at 10 AVP, we have how many hours of data we can. Yeah, we've got about 100 hours of video we can store. So yeah, these are going to be mounted on the side of the rocket. I think at this height.
A little lower, yeah, on the booster.
So we've got one on each side.
Sounds good. And what types of battery are you using for both your cameras as well as for your flight computers?
Lithium iron phosphate batteries. So LiFePO4. And for the cameras, it's 9-volt alkaline batteries. And I think we were going to use the same 9-volt alkaline batteries for the COTS altimeters.
Got it. And have you done any testing or calculation for how long your batteries will last on the pad and during flight?
No, that's not done yet.
Was it no?
Yeah, that was no.
Okay. Yeah, just want you to make sure you're thinking about that as well. Oftentimes teams may end up sitting on the pad. If there's any delays, it could be for a couple hours before you launch. So not only do they need to survive a long time, they need to survive a long time in the heat, and then also still have enough power left to be able to power your computer during flight and be able to still deploy your charges. So I'd recommend doing a little playing around testing, some calculations on how long those batteries should last, just to make sure that you have enough power to last multiple hours out on the pad.
Our target, I think, was 24 hours. So we haven't tested it yet, but that was our target while choosing everything.
Sounds good. Yeah, that should be more than enough, but I'd rather it be too big than too small.
Yeah.
Okay. I think we can then move a little bit lower in your rocket then. I don't think I have any more questions regarding the avionics bay or the payload.
Yeah. So we getting more into the drogue side on the fins right now?
Yeah, so I guess maybe I do have a question on your couplers. How long are those?
There is one caliber that is thick inside of the tube and 1.5 that goes in the other side. So there are 2.5 calibers.
Perfect. Awesome. And then your drogue is down there, just pretty much the same points and questions that we had talked about with the main parachute. But also then that added point of, since you're using nylon for that chalk cord, make sure that that's protected from your deployment charges as well.
Okay.
And then my next question on the drogue would be, how is it attached to the bottom side of the rocket, to the booster?
It's kind of the same principle done with the main. So we have a bulkhead right there with 9-volt 3.8 on it, and we have another bulkhead right there with the same 9-volt. So it's and they are still screwed with M5 on directly on the fuselage. So yeah, this is
okay. Sounds good. And then below that you have your centering rings and your motor mount tube. I didn't have any concerns there. Your fins look great. My last question for that would be then, how is your motor retained?
The motor, so basically we have, I can probably show it to you better. So I'm just gonna take it's the same retainer than last year's rocket. So I'm just gonna show you last year's rocket since we don't have the thrust plate yet. There is the thrust plate right there that we can see that basically pushes, transfer all the force to the rocket. Then we have a cuts retainer right here that's bolted onto the thrust plate. So we put the motor in with the motor tube, and we basically just retain it with, by screwing it in. So yeah, we just need the thrust plate to do it on our new rocket. So yeah.
Looks good, no concerns there. One more question about your motor. You said that was getting delivered to the competition, is that correct?
Exactly.
Okay, and does that include the casing for the motor as well, or do you already have possession of that?
The casing and all of its part, there is I think there is like a closure, and there is we have the old kit and the recharge at the competition. So we have an so yeah. All of the
Sounds- What motor were you flying on?
It's a M200 2500 yeah, Aerotech.
Sounds good. Nice motor. Let me see, make sure I'm not missing any other questions. I don't think, oh wait, actually I have one other question that I forgot to ask you, and that's just for arming your flight computers. What type of switches are you using for that?
So Nathan, yeah, Nathan is not here right now, but they will be back soon. For the usually we want this year they wanted to design a kind of a push pin, so it would screw into the rocket and activate basically every switch sequentially on the rocket. Yeah, well, right now it's I'm gonna wait until Nathan comes back, so we can talk about it more. But we also I can talk about a little bit of what we did last year, because this will be like a backup solution in case we aren't able to fully design it.
Sure.
Last year we basically used switches, mechanical switches. I have them back here on avionics bay. This is last year avionics bay, and it was basically we have those mechanical switches right there. We put them vertically so the force, the G force, would not impact them. And with our vent holes, we basically were able to activate them by. And we knew our flight computer was on because we could receive the GPS signal. So we knew it was on. And for the altimeters, well, they would beep us the information and the continuity checks. So yeah, so this is the backup solution, but we have but they are on their they have still the push pin model in conception. So, but
Okay.
this is backup.
And do you have vent holes on your avionics bay already this year?
No, we have all the vent holes are made except the one for the avionics bay, just in case we need to place them strategically.
Sounds good. And I see you have your rail buttons attached, correct? Okay, and how are those attached to your rocket?
They are 15-15. They are cuts, so we didn't make them. They are basically we can kind of see them. They are screwed.
Oh, okay. Perfect. That's good. And then I just want you to confirm and make sure that when you're drilling those holes to arm your flight computers, that they are not in line with those rail buttons. Make sure that when your rocket is on the pad, you're actually able to turn on those flight computers. Otherwise, it will cause a lot of delays if you have to take it off. Yeah,
no problem. We also planned on putting our antennas on the other side also, so they don't bounce back on the rail also, just in case. So yeah.
Sounds good. Okay, now I think that covers all of my questions for the rocket specifically. Does anybody else have any other questions or comments about the rocket design?
I might have one question real quick. Kicking back towards the deployment side and the deployment charges test as well. I know you guys are using Pyrodex here, but you're not going to be able to transport that all the way to the competition. You're going to have to use black powder over there. So there's going to be a different ratio between what you end up testing with your Pyrodex and what you're going to have to put as far as black powder goes into your charges. How do you tend to alleviate, that challenge? Are you going to be testing on site once you get there again to make sure whatever you calculated is fine, or?
We arrive 1 day before the opening ceremony competition, so we plan on doing an ejection test on this day.
All right. So
And we already have a black powder confirmed to us with Wildman Rocketry. So
all right.
Justin, I have a question.
Yeah.
Can you show us the fillet on the fins?
Yeah.
Because there was a team last year. I think the curvature was okay. So you have inside also.
Well, there is it kind of like I guess.
Because you mentioned a tip to tip, except if you did your tip to tip with fiberglass, I don't see the tip to tip.
You don't see it, the fire? Okay.
Is it with fiberglass? It's not carbon
Yeah.
fiber, the tip to tip?
Yeah.
Yeah, it's fiberglass, so we can.
Okay.
Right there, yeah.
And yeah, so your fins are also reinforced on your motor tube as well, right? So
Yep.
you've got internal fillets as well as external fillets then.
Okay.
Yeah, exactly.
All right.
Oh yeah, the internals right. Okay. And yeah, there was 2 fillets basically.
Okay.
I think that all looks good. Any other questions or comments regarding the actual rocket?
Not on my side.
Oop. How many? You calculate how many calibers you're gonna have?
It's 2.5 right now of stability.
Okay. Launch early in the morning.
What?
If you don't want to walk, just launch early in the morning.
Yeah.
At 2.5, you may have a nice walk for recovering.
Is there a particular caliber too? Because we know we need
The 2.5, well, you're close to you're not too far, but well, depends.
Okay.
A windy day, it can be a problem. I will water cock a little bit more.
Okay.
Not that I think with the motor you have, you're gonna have a nice velocity at the end of the rail.
Yeah. We are at 100 feet per second, right on it right now. So I know this is what was recommended. So.
Well, it's more like at apogee, it may bend a bit earlier than if you had a smaller caliber, but it's okay.
Yeah, and I will echo the importance of launching early. I'm not sure if your Mentor's Flyers records have been there in recent years, but especially last year, there were some major
Yes.
issues with the wind.
Winds.
At Spaceport America Cup, it gets very windy, especially in the afternoons. The mornings are usually relatively calm, but by the time it hits about 1 p.m. or 2 p.m., I would expect it to be too windy for any rockets to be launching. So if you want to launch that day, you should be ready early in the morning. How it's going to be working this year is for the solids pads, there are 20 launch pads. So that's 4 groups of 5. So that's 20 of you that are going out at a time. And it's all first come, first serve. The first people who finish up their rocket, take it to that final safety check. That safety check at the launch site is just pretty much make sure you have rail buttons on, that your fins haven't fallen off, that you put your shear pins on. So it's not a very big safety check. But the first people in line to do that and then get into the queue are the ones to go out. So if you're number 21, you're waiting for the next group. It likely will be 2 to 3 groups of 20 that get a launch in a single day.
Yeah.
They're putting in a lot of effort to try and speed things up this year compared to last year, and also to open the launch site as early as possible. So that means on Wednesday, on that first day, try and get out there and launch right away. They may end up launching as early as 8 a.m. For some of the following days, they may try and get it open as early as sunrise. So I'd be there when the gates open, so you can get out there, finish prepping your rocket, get in line, and get launching, just so that you're not delayed by the wind.
So they're gonna open the gate around 6?
Yeah, that is still being finalized. It has to be worked out with
The
the
base?
Mexico Spaceport Authority at Spaceport America Cup. But in the past, they generally opened up the gates at 6. This year, they're trying to open them up more like 5 a.m.
Okay, because there was a really long delay on the first day was quite a long delay before they let us go in.
Yeah, I know that that's definitely been an issue before, working with Spaceport to sort out all of those exact timings. So it is something that is being trying to be addressed this year to try and get teams in as early as possible. Ultimately, I know in previous years we've just seen like a bit of traffic jam in there. If all 100 teams show up right at when the gates open, it's difficult to let all 100 teams into that student prep area. Otherwise, traffic just can't move. So you might have seen in previous years, like they let in 10 or 15 cars and then they pause for a few minutes. So even then, I think it's worthwhile to get there, wait in line. A bonus is if you get there before the sun rises, it's really good
Really
stargazing.
nice, yes.
And it's nice and cool in the morning, and
Yep.
beautiful sunrises out in the New Mexico desert.
Yep.
So definitely just try and get there even before the gate opens is what I'd recommend if you want to launch early, which I encourage all teams to.
That means really, really early, Justin.
Yep, and little tip as well, if you want to make it as efficient as possible in the morning, practice your checklist and do dry runs as much as possible beforehand so that when you're on site and you're on the day launching, you don't spend 4 hours trying to build your rocket and fly. It's going to be too late by that time. So
Yep.
Dry runs.
How many teams on the solid pad in total?
How many teams? There was 155 accepted. A number of teams have dropped out. I think we're sitting at about 130 right now.
Okay.
But to the point about checklists, that is another thing I wanted to talk about. Were you guys able to make a pretty thorough checklist for your technical report?
They are on our technical report right now. Yeah.
Okay, yeah. Definitely, like I said, continue to review those and modify them if you need to. You don't have to use the exact checklist that you put in your technical report. It's kind of expected that you'll do some practice, you'll find some things to change and update. And that is something that will be reviewed at your in-person safety check. So what you should plan on doing with your checklist is have it printed out, bring it with you. I honestly recommend printing out your whole technical report and bring it with you in a binder because it probably has numbers and references that you might want to point to or diagrams during your in-person safety review at the competition. But especially the checklist that will be reviewed closely to make sure that it is very thorough. I like to think of the checklist as something where you could hand that to any single person on your team, no matter how involved they are with your project, and they'd be able to safely and successfully assemble and launch your rocket. So that includes PPP, all the steps, how big your black powder charges are, everything you need, because you're going to be at the competition and it's going to probably be hot and windy, and you're probably going to be really tired and a little distracted. So having that checklist is really important. Not only that it's thorough, but that you're actually following it at the competition, and that will be checked.
Okay.
And don't forget to bring it to the pad with you.
Yeah.
Yes, that is where it will be most important. If you show up at the pad without your checklist, you will be turned around and sent back.
We'll print a bunch of copies. Yeah, make sure. But yeah, so maybe we can go back to the arming system. Nathan is right now. So I talk about like we could use switches in the secondary if just in case, but we have a push pin, I think, idea that was initially
The arming?
Yeah, for the arming system. Yeah.
So basically, the design hasn't been completed yet, but basically the idea was that for the can we just turn the camera
You
around?
can, if you want to do this.
Well, not really, but so basically the idea was that the pull pins were kind of a hassle because we had to they have to be inserted in, right? So we figured it would be better to insert them to arm the systems. So basically, we were gonna have I think 6 pull pins or 4 with dual switches, basically. So one pull pin would switch on two circuits, and so we would insert them to activate that particular circuit. So put it in halfway, we hear like the beeps we have to hear, then we push it all the way in, and then we screw it with an Allen key on the side, screw it in place so it stays there. That eliminates maybe potential problems with vibrations, so the switches can't flap on and off, and since everything is sealed tight, and yeah, that was the idea.
That sounds good, and I like that you've addressed that you have some way to keep them in place and locked.
Yep.
That will be important, and it make sure that you probably practice arming those, because when you're at the competition, you'll likely be up on a ladder. It'll be windy again, and you don't want to be sitting there futzing with your switches on the pad trying to get those to turn on.
Yeah, the biggest issue for me with pull pins is the alignment of the holes. But if they're, when we insert the avionics wave, we can see they're aligned. There shouldn't be any problem on the launch pad. And we're putting them low, also as low as possible, to ensure that even the smallest ones of us can push them in. Yeah.
Sounds good. Yeah, that's good to hear. I like to hear all the precautions that you're taking and that you've thought about that. Okay.
Maybe a question before we go to the next part. I was wondering if our flight computer, our SRAD flight computer, cannot be the arming the charges. Can it be considered a payload if it collects data and telemetry and stuff?
Yeah, you could still consider that a payload, assuming that it's then following all of the payload rules, form factor, weight, size, things like that. Then you could consider that a payload.
Okay, cool. I think that was all my questions. Maybe I had something else. I don't remember. Anyway, thank you.
I do have a couple other logistics questions for you guys. Since you are an international team, I just wanted to make sure that all of your students who are traveling to the competition have their passports.
Yep, all of them.
Okay, good to hear. And did you get the pre-registration form submitted on time?
Yeah.
Awesome, that is good to hear.
Yeah, we had two people who had not received their AAA acceptation yet, so we confirmed this on site, so we sent another one.
Yeah, the registration team, I'm actually part of the registration team. We're working on going through all of the team's pre-registration data. And so we'll flag anything that needs a little bit more information. So likely those AAA cards, and we'll reach out to you if we want that data. Otherwise, if we don't reach out to you, you can assume everything's fine, but you should still have everyone have access to their AAA cards at the competition. So I think you have virtual cards. Just make sure people have them downloaded.
Yeah, we're gonna print them out just to be sure.
Maybe another quick question of logistics while we're at it. Speaking of passports, do you have any international students or like exchange students that are thinking about coming to the competition, or?
Everyone has a Canadian passport.
Okay. All right.
Double check, but everyone told me that.
It's a lot simpler that way.
Yes, French people are hard to pass. Rocket is easier to cross the border than French people.
Yeah, you usually put them all in the same car.
Yeah,
and,
just because I'm with another team in Montreal and they have few French people, and it's always the funny part of the Rocket. That's fine. French people, okay, stop there, guys. They push away because they have French people from France.
Yeah, I can't imagine you all will have any issues with your Canadian passports. But I do want to remind you that in between where the convention center is and where the launch site is, pretty much everybody drives that same road. There is a US border checkpoint. Oftentimes during the morning of the competition, they wave just about everyone through, but they may stop and ask you if you're a US citizen. So when you're going to the launch site, you should have your passports with you so you can provide identification. You should really carry them with you almost at all times, just because we're so close to the US border, or to the US-Mexico border there. All right, I'm gonna turn it over then to you guys. What other questions do you have about the competition? It can be anything from logistics, what to expect, anything and everything is fair game.
I think you sent that email. So for the rule for 200 milliwatt transmitters, we had to have a meeting, and honestly, I forgot about it for a pretty long time. And I thought maybe that would be part of this meeting. So, or if it's not, can we have like maybe more information on what you would need to know for that?
Sure, yeah, so, I mean, that's only required if that flight computer is also controlling deployment charges. So if you don't think that you're going to flight test and have your flight computer ready to control deployment charges, I'm gonna say you don't really need to bother with doing that review. However, if you're not, I'm not gonna be the one to do that review, just because that's not really my area of expertise. We have another other volunteers and kind of RF focused safety reviewers who are conducting those reviews. So I believe I had sent you a link to fill out a form. Did you fill out that form?
I don't remember. I don't think so. Probably not.
Okay, yeah, if
But we won't be it'll be part of the payload. It won't take back charges. We can't flight test it in time. That's for sure. So,
Well, there is
but just for info, I'll look at that. I guess that
there is a CQF event normally next week.
Yeah, but we got no rocket.
Well, we do have they'll genre Valomite on it. I'm gonna have my
Yeah,
own
but
one
it doesn't
engine.
fit. It doesn't fit.
Yeah, it
Like,
fits. It's 4-inch. It fits.
Yeah, but the RSO that I'm not sure is the RSO is seeing your presentation now, and I'm not sure I want to see that thing flying at my. I want. You're gonna be really precaution with flying and turning that things on. Can tell you.
yeah. So ultimately, to answer your question, if you decide not to fly it with, not do the flight test and connected to black powder charges, you don't need to take any actions. If you do decide that you're gonna try and pursue that sooner rather than later, go back in that email and fill out that Google form. And that will be sent to the team just so that they can collect information, and they'll reach out to you as needed, to chat more about that.
all right, good. Other questions? No, nothing comes to mind from you.
Let's see. I don't know if you guys have any other questions.
I have one other question for you guys, and I just want to make sure that you are familiar with what the schedule is and what each day of the competition and what you can expect on those days.
It's our first competition for our team, so yeah, we would take the advice.
Yeah, just making sure that Monday, you'll get a response probably in the near future regarding what time you should be there, because you would sign up for those time slots for registration. So you'll get an email regarding when you can expect to go there. But remember, for that Monday, you will be doing your in-person safety review then, so bring your whole rocket, make sure you have all your components. Just make sure you do not bring any energetics into the convention center. So no black powder, no rocket motors, none of that. Leave that all at home, but bring everything else with you for your safety review. You'll also be doing your team photos. And then at the end of the day, they'll be doing a group photo as well. And then Tuesday, there's additional safety reviews if you need to do any remediations, conference day. But then of course, Wednesday through Saturday is launching. And I know we already talked about that a little bit. But an additional comment that I wanted to make is, are people on your team familiar with sort of the desert environment that this launch will be occurring at?
I don't think so.
Yeah, I think we can generalize and say no.
Yeah, it's a desert, and it's a higher altitude desert as well. Your altitude's at 4,600 feet, and so even if you already know this, I'm going to remind you anyways that the environment is tough out there. You should be bringing a lot of water with you, more than a gallon per person per day. Bringing extra water is never a bad thing. Bring a lot of water and then bring a lot of extra. Electrolytes are also your friend, Gatorade or Powerade or whatever you like. But also just how you dress is really important out there as well. So make sure you're wearing Like long sleeves are always recommended, and long pants. They should be breathable material, so nothing really heavy or not breathable. You'll get really hot in that. But the lightweight material is good for sun protection and from the heat. The most common sort of injury that we see, or the biggest issue that we see at the competition overall, is students getting some sort of heat exhaustion, sunburnt, just heat related issues. So do a little bit of research on sort of those desert environments and what to wear and what to bring, just so that you can be fully prepared. That includes a wide brimmed hat. Just a baseball cap's not really enough. You want full protection on your neck and on the back of your neck as well. Sunscreen, of course, sunglasses, and make sure that you're wearing appropriate footwear. I kind of like to say that assume everything out there in New Mexico, all the flora and fauna, is mean or wants to hurt you. It's unlikely. The heat is a lot more dangerous, but the bushes are very, very thorny. If you're wearing tennis shoes, it'll go right through. You should be wearing some thick-soled boots, especially for people who are going out on pad into recovery. Hiking boots are great for that. Definitely, nobody should be wearing any sort of sandals or flip-flops out there. There's just little bugs and critters that you don't want to encounter. But I think that's my whole pitch for the desert. So do a little research, come prepared, and you'll have a good time.
Good.
All right, I don't have anything else. So unless anybody has any other closing questions or comments.
I may have one for registration day. How many people need to be there for the registration? I don't think the whole team needs to go there the first. Maybe for the team photo, but before that, I think I don't know how many people need to be there just to make sure.
Yeah, it's not strictly necessary that all of your team members are there. The people who are definitely required is your team lead and anybody who's needed to have expertise for your safety review. So make sure you have all your sub-team leads, or however your team is structured. Make sure you have all the people who have all that knowledge. Make sure they're able to answer questions. But you will probably have to wait a little bit. So when you get to the convention center on registration day, you're going to send just one person. Your team lead is going to go over and check in at the registration table. And that should hopefully be pretty fast because you've already done the pre-registration. And then right after that, once you're checked in and registered, you'll go and you'll get in queue for the flight safety reviews. And this may take a little bit of time of waiting for a reviewer to open up. And so there's a queuing system that's being put in place this year. If you're familiar with like a restaurant wait system where they have those table buzzers, where if you go and there's a wait, you get the buzzer, and when it's your turn, it buzzes to have you come to get your table. It's a very similar system as what we'll be using at Spaceport this year. So I'd expect a little bit of downtime in there. And that's a really good time for you all to go get your team photo. So for that reason, you may want to have everybody there, but also a lot of other teams will be in and out of the convention center. You can start setting up your table for the conference day if you'd like. So you can have team members doing that. And then again, at the very end of the day for the mass group photo of all the teams and volunteers, you'll want everybody there for that. So strictly, they don't need to be there the whole time, mainly just for the photos and then the necessary people for your reviews and check-in.
Okay.
Yeah, I'm all good.
Yeah, I'll do from my side too. I don't know. Yeah, I'll do. Don't know if anyone has any more questions, but yeah.
All right, well then I think we can wrap it up here. Thank you guys, this was great. You guys are in a really good spot, so I'm very excited to see you guys out at the competition and watch you fly. I'm sure it's going to be a great flight down there. So good luck in your last month leading up to the competition here. Again, make sure to send this recording in to the Ezra General email so that it'll be posted up to the YouTube channel.
Good.
All right, well, thanks for having us. We'll see you at the competition, I guess.
Sounds good. Have a good evening.
Have
Bye-bye.
a good evening, everyone.
Thank you.
Goodbye.
Bye-bye.
Bye. Espérons que ça l'a enregistré. Parce que... Ça devrait enregistrer dans le cloud, que ça me dit. J'espère que c'est vrai.